All right. Yeah, there we go. All right. So again, my name's EJ. Andrew's going to help me out a little bit, especially when we get into the hands-on side of this. I'm going to try to speak in front of my computer. It's not that I don't want to get close to you guys, but I do want to capture as much of my audio as I can. So tonight we're going to talk micro automation using the Siemens logo. I started teaching with the Siemens logo in 2005. So this is 20 years ago. I started teaching with the Siemens logo. It was legitimately they number the logos as OBA 0, OBA 1, OBA 2, OBA 3. Now officially they're like an OBA 8 is what they're at. And so in 20 years, they've gone up 8 revisions. And when they first started this thing, it was really nothing more than a timing relay is what it really was. You could time, you could count, you could do some very basic logic instructions, and it's really come a long ways since then. So let's talk about what we're going to do. It is important as wherever you're sitting, make sure you're close to a power outlet. So like Blake back there, you guys want to make sure you got a place, there's a power cord there. I try to put computers close to power outlets so you guys have power because we will do hands-on. So if you have never programmed a PLC, tonight you're going to program PLC, and I'm going to tell you what, I couldn't be talking to a more diverse audience right now. I've got people in here who can't spell PLC, Tom, and then I've got others in here that have been programming PLCs for 20 years, and some that have, probably, like Bob or somebody who's done the SCADA and all the behind-the-scenes stuff and has forgotten more, than I'll ever know about PLCs. So, I mean, there's literally everything in here. So I've aimed it a little bit more at the lower half of that, but for those of you that have a little more experience, there'll be stuff in here for you as well.
Did we meet because I brought you information about logo when I was working at Siemens?
Almost guaranteed.
Yeah.
Almost guaranteed. If you were on this campus, you would have met with myself and a gentleman named Jerry, and we were running only Allen Bradley controls at the time up in electrical.
Yep.
And Siemens came in and they wanted to start to steal market share away from Rockwell. And so you guys gave us a bunch of really early on stuff, even some of these little white boxes. I don't know if you remember the little white boxes that had the little switches and little LEDs, and that was my first experience with the logo, and I just
that's what it came.
I kind of fell in love with it. It was absolutely awesome.
That was the IO.
That was the IO. Yeah, it was one little box. It was like a little trainer unit. It was absolutely awesome. So there's 8 slides, 3 demos, and 2 instructors that are helping out tonight. So there's only 8 slides. That's 8 slides that we have tonight. So, all right. So what are we going to talk about tonight? What is micro automation? We'll talk about the Siemens logo hardware, the Siemens logo software. We'll talk about digital and analog instructions a little bit. We'll get into the basic functions of logo. We'll talk about special functions of logo. And then we have 3 demos that we're going to do. We'll do a tank fill, we'll do a parking gate, and we'll do some basic lighting control is what we're going to try to do. So, no. No, like the parking lot lights. So no lasers tonight. All right, so what is micro automation? And so this is kind of my own terminology as I've seen it over the years. You can get, so if you look at like Rockwell, and several of you in the room are familiar with Rockwell PLCs. Rockwell they have micrologics, they have compact logics, they have control logics, they have RS500, they have RS5000, they have Studio 5000, they have Factory Talk, right? And when you talk about Rockwell, you're probably talking more like a micrologics PLC. But that being said, Allen Bradley actually makes a smart micro nano, I almost want to call it a nano PLC, very similar to logo. So I believe Allen Bradley might be the Zelio is what it's called. IDEC makes the smart relay. Telemechanique makes one, I can't remember what they call it, and then Siemens makes the logo. And the best I can tell, Siemens was kind of the first on the market with this. I don't know, if they originally designed it, but everybody else has kind of copied it since then and tried to do something. So what is micro automation? I would say it's a PLC application that requires less horsepower than a traditional PLC. Traditional PLC, when I order a L18 ERM PLC for the controls lab, you're looking at $600, $700, $800, depending on the IO. You could be looking at $1,200, $1,500 as you expand out. If you're ordering a compact or control logics, you could get really, really expensive in the order of thousands and thousands of dollars for one simple controller, right? And then on top of that, Rockwell's a software company. So they're also going to charge you for the software on top of that as well. So you're paying for all those licenses. The neat thing about a Siemens logo, I could go to DigiKey right now. I'll actually do it while I'm sitting here recording my screen. I'm just going to go to digikey.com, but I could type in Siemens logo. And when I type this in, I don't know what they're charging for it. I think it's probably about $300. We'll see here. They'll have a bunch of different versions. I'll see what's in stock on DigiKey.
8.4. Look at that.
Logo 8.4, they sell it. And when you go down here and look, you can see that the pricing ranges from, I don't know, about $250. No, not even that, $200.
Yeah.
So as you look at these, you'll see the different models. The Logo Pure doesn't have a screen and it doesn't have the keypad. So the only way to program it or make any adjustments is through the software. However, when you get into the Logo, you'll see it has this keypad and it has the screen. You can legitimately program your entire PLC program from the keypad. And when you're done doing that, you're going to want to poke your eyes out with a sharp stick because it is not fun, right? It's like if you remember the early cell phones when you texted and you had to like hit the one button like 16 times to get to the letter that you wanted to get to and then hit the two. That's what it's like programming the logo through the keypad. Through the front panel. Through the software, it's incredible.
Yeah.
Now, what's good about the front panel, though, and I've seen this application. I was at Summit Brewing. They're using the logo to fill kegs. Yep. And what they did at Summit Brewing was they actually said, hey, I need to make a modification. We need a little time delay on this. The time delay is not long enough for the keg to be seated. And, once they sense it, it kind of shifts around a little bit. So they wanted a little time delay for it to kind of settle into place. And they didn't have to break out a computer. They could go to the front keypad, go find that timer, and just change that variable in there, right? So change it from a 1 second delay to 1.5 or 2 second delay. And now all of a sudden, if you're just making a very simple parameter change or, a preset change, super duper easy from the keypad. Programming it from the keypad, not too fun. So a little bit more expensive to get the keypad, a lot less expensive if you're just going to get the pure.
And that application was pure.
What's that? So from the cybersecurity guy in the room, this is a true statement. Yeah. So for those listening to this online right now, anybody could walk up to this and make changes to your program. You're going to have much more difficulty tapping into this one. That is a true statement.
And Logo is on the Surly brewing system because it's a brow mat. Siemens designed brewing system.
That's correct.
So,
yeah. I was speaking Summit, but the same thing on Summit.
Yes,
the same. What you'll find with a lot of the breweries specifically, they buy gear from where? Germany. And where does Siemens come from? Germany. So it just makes sense that a lot of the gear that you would buy is spec'd out for Siemens hardware and Siemens software.
The monks originally created this logo.
I'm not sure that's the case, but maybe it is. I'm not sure. All right, so applications that require less horsepower, logo's perfect. Applications that use less I/O, the logo is perfect, right? Applications do not require mathematical algorithm development. So if you want to do something like do a PID algorithm or you want to do some sort of fancy scaling or something like that, this is not your tool for that, right? You're not going to get your set math instructions like addition, subtraction, multiplication, or exponential, or God forbid any PID type work.
But you can do function blocks.
You can do some function block stuff, absolutely.
So you can do some recursion.
Yep.
More advanced programming.
Yep. You'll see really quick. You can get advanced. I just know that there's going to be a tipping point where you're going to be like, I probably should have picked something bigger than the logo. Yeah. But in most cases, this thing's going to work. And then the best thing here, low cost applications. There's been vending machines built around the logo. There's parking gate arms built around the logo. There's parts of brewing processes built around the logo. Quick Trip car washes had logos not to run the car wash, but there was little PLCs at the entrance door and the exit door to actually open the car wash door. There was a logo. Just so I'm not just full of blowing smoke here. I'll just show you an example here. This is an old picture, so you guys got to bear with me here. But 24 years of doing this, I've collected a lot of pictures here. And I was fortunate enough to actually, Blake knows this company, Reliable Plus. Reliable Plus was acquired by LubeTech, right? And so LubeTech is where Blake worked. And so the interesting thing when you go to look at a Reliable Plus car wash, you'll see all these contactors. You'll see all of these different boards and stuff. These are some old pictures. I apologize. But when you look at, you'll actually see in this particular version, the PLC up along the top, I believe is a Panasonic. No, it's a Mitsubishi PLC. Yeah. I take that back. And you'll see a telemechanique drive on there. But if I go far enough, yep, that's Mitsubishi. And then it's not a logo. Oh, I lied. It's not a logo. What is it? It's a logo clone is what it is. Yeah, so this is, I was thinking it was a logo. It's actually not a logo. So remember earlier I said Allen Bradley's got their version, IDEC has their version, everybody's got their version, right? IDEX is called the Smart Relay. It's almost a little bit crazy that they get away with that. It's almost like Siemens is producing them, selling them, and snapping a different cover on them. Well, because because I think you could take the logo cover off and it would snap right onto this and nobody would know the difference.
It's a German company too, is it not?
I do not know if IDEX is a German company. That's a good question.
It's probably made by Omron. In the Southeast, now is doing a OT security assessment for one of the largest water districts in the Southeast, and at 70 well sites, they've got a Motorola RTU, an AC 3600 or something like that. But then that runs off Modbus RTU to a Micrologix, and they're pulling in Micrologix for the photo beam at the gate, for the door strike sensors, and then for tank level and chemical level sensors. So it's like half of it is your process control, and the other half is access control, which I thought was ingenious because they would have had to extend, a little bit more Ethernet. It would have been all this other network segmentation. They said, well, it's just signaling. So they just ran the signaling into Micrologix, which I was like genius. Just analog, and then they relay that through the Motorola, and that pops in with the SCADA, and then that's what gives them their
so
their
cool
real-time indication of the somebody going through the gate and crossing the photo beam or opening up a door.
Yep.
So there's all kinds of these different little micro automation examples that you can tie in that you would associate with like a standard security system.
Yeah. Well, and where it really hit for me was I went online one time and I just wanted to order, this is probably 20 years ago, I wanted to order a timing relay. And I went, just a simple timing relay. And I went online onto DigiKey and I looked at a timing relay. And the timing relay, it was with the base and everything, it was pricey. It was a good timing relay with the, had a couple of dip switches where you could change it from seconds to minutes to hours. And it just had the big knob like you'd see on the old style timing relays. And you could set it from like 0 to 60, but it could be 0 to 60 seconds, 0 to 60 minutes, or 0 to 60 hours, depending on those dip switches. And I was on there and I'm looking at it. And at the time, this timing relay with the base was like $89 or something. I was like, holy cow. So then I went on just to look to see what a logo costs. And at the time, the logo was like $149. Yeah. And I was like, are you kidding me? For $60 more, I can get a PLC with software and the ability to change it via keypad. And I was like, you got to be kidding me. So I was like, yeah, it is basically when you look at these simple examples, these micro automation examples, timed events, counting events, lighting controls, irrigation systems, simple temperature control. Now, when I say simple temperature control, I'm thinking almost like your furnaces, right? The logo can monitor the temperature, kick a fan on or kick the heat on or, kick the cooling on. It's probably not going to zero in like a PID or something like that. But yeah, simple on-off control. That's perfect for temperature control, right?
For a tank, for sure.
Yeah.
It moves slow.
Yep.
Here's a logo on Amazon, $98 delivered on Wednesday.
$98 on Amazon delivered on Wednesday. Yeah, so DigiKey is not the cheapest place to buy a logo. That's for sure.
You got a home project?
Yeah.
Yep.
No.
I always like this one, like sump pump control and monitoring. So if you got a sump pump, you got that float switch, you could hook up an alarm to it. You could hook up battery backup to it. You can do all these different things, right? That's another neat thing about the logo is the 1224 RC version of the logo can run on 12 volts or 24 volts DC. So I've seen a sump pump application where they're running on AC power with the DC power supply at 24 volts DC. The backup is a 12 volt DC car battery. And so in a pinch where power goes out, you still have power to run your pump, you still have power to run your logo, and you can still sound an alarm or do something cool with that. Exhaust fans, all of that type of stuff. These are simple applications for a PLC, right? Micrologics even would be overkill for any of these applications. You'd be using like 3 inputs and 2 of the outputs. You just don't need that much power.
They're perfect for home use.
They're
Doing
incredible for
DIY
home use.
projects at home.
Yeah.
They're great for that.
What's interesting also about them is unlike, I mean, most PLCs are going to have a real-time clock access, right? But the access to the real-time clock inside the logo is actually intuitive. You know, it looks like the Windows calendar, right? Like I want to turn my irrigation system on Monday, Wednesday, and Friday. I can turn it on Monday, Wednesday, Friday. I want to have 4 zones that go 1, 2, 3, 4. I can have 4 zones each 15 minutes. I could do that all with the logo. And if I wanted to change some settings, I could do that with this. I mean, so could replace your Rainbird irrigation control or something like that. Not that I would, because I think the Rainbird ones are built, they're actually pretty nice. 8 digital inputs on the logo. You can also get these with AC inputs as well. Most of the ones I see are digital inputs. The thing I like about the 8 digital inputs is when you buy them as a digital input. So the first ones I used never had analog on them. Now, 4 of the inputs are analog or digital. So I1, I2, and I7, and I8 can be configured as analog or digital. I3, 4, 5, and 6 are always digital. But you can use 8 digital inputs, or you can do 4 and 4. You can do whatever you want. I love the relay outputs. I absolutely dig relay outputs. The reason why I like relay outputs, I want to run a 24-volt DC fan. I want to run a 120-volt pilot light. I want to run, 240 on something else. Each one of those relay outputs is rated for 10 amps. So you can treat this thing almost like a motor starter at that point, right? I mean, it's pretty. Yeah, it's very, very robust. Yep. Optional HMI. So the logo TDE was the thing that we had originally, which I think it stood for Touch Display Extended. It was basically a replication of this little touch display with the screen, and it was on a separate screen that you could put on the front of a control panel. So you weren't like trying to access this from the front of a control panel. So they would use it like an HMI. But now recently, the KTP 400, which is the Siemens programmed in Siemens TIA portal, actually can be configured to talk to the logo, which is crazy in my mind. That was nothing in the past. Ethernet programming communication.
That's taking a page out of Alan Bradley's legacy PLC support.
Yes,
He's
yeah.
just bringing all that stuff forward. Being able to go back, 10 years.
Oh, yeah.
Which isn't very far.
No. Keypad programming, low cost, approximately $300. And then you can expand these. So you can buy a brick that plugs into the side of this thing that adds 4 inputs, 8 inputs, 4 outputs, 2 outputs, analog. You can expand. So you can treat this thing. It can look like a PLC when you start stacking stuff. Now, at that point, I question, why you wouldn't go to a Micrologics or something, right? But if you can, like, if you just, yeah. I mean, here's the deal. If you only need 1 or 2 more inputs, grab the expansion module, right? And the expansion modules are even cheaper. All right. What makes the logo the best, especially when you're teaching PLCs to students, is really logo soft comfort. It is the ultimate in a programming language. It has simulation built into it. It has kind of emulation of the hardware built into it. I'll say IEC 61131, we only actually have 2 programming languages. We have a user-defined function that we can do as well, but that's actually defining a function within a block, which is a little bit different. But we do have ladder logic, and we do have function block diagram. So you're not going to get sequential function chart or some of these other things that you would get with a higher-end PLC. So you're down to 2 programming languages. Mind you, for most of us in the room, we love programming ladder logic, and if you don't, you're probably okay in function block, and they both work really, really well. Simulation and emulation, simulation and hardware emulation, I'll show you that in a few minutes. Really cool thing, especially if you're student learning, you can convert directly from ladder to function block or back. I have not seen another PLC do that. So you can write all your code in ladder, click one button, and it'll show all your code in function block. And you'll have both programs sitting side by side. So I've had students that said, God, I want to learn function block. What better way than to write the code in ladder, shift it over, and then kind of reverse engineer it and see how you would do it in function block, or vice versa.
It's great for logic, review.
Oh yeah, it's incredible for that. There are 2 new things that I'm not as familiar with, and I'll be honest with you, Logo Access and Logo Web Editor. So what these are, Logo Access allows you to dump and log process variables, kind of like a historian almost, but into Microsoft Excel. So you can set a timing to actually record data into a Microsoft Excel spreadsheet. That is Logo Access.
Historian.
It's basically a historian. Yep. And then Logo Web Editor, which allows you to create HTML web pages where you can log in from your phone or log in via the internet and actually look at this thing and look at all the I/O. So yeah, yeah. So Paul Bieneman's is for those listening online. Paul's alarm bells are going off right now.
Yeah.
He's thinking about all of the great cybersecurity measures we're putting in place here. So this is good.
I say 95.
Yep. So then when we get into instructions, the other thing I really liked about the logo that was really cool is at one point I ran out of inputs. We were doing something with inputs similar to what we're doing with the Emerson tank, but this is probably 10 or 15 years ago. And we used up all 8 inputs, me and a group of students. And we're like, we're out of inputs. And I was going to order an expansion module. And one of my students realized something. He's like, EJ, you don't need an expansion module. I go, what are you talking about? Those cursor keypads, those cursor keys can be configured as input push buttons. So you get your 8 inputs and your 4 outputs, but then you get an additional 4 inputs off of those cursor keys, which is pretty cool. So you have to configure them, and to use them, I think you had to hit Shift or you had to hit something with the button to make it work, but it worked great. I mean, it actually was pretty cool. So the cursor keys are inputs. For those of you guys that are Rockwell folks, I like the fact that Siemens uses I and Q because I think Q is a better term for output because it doesn't look like a 0, right? I actually I think it's Mitsubishi, which I like the best, which is they use X and Y as inputs and outputs. And the reason why I like that is if I got an undergrad in mathematics, and so in mathematics, everything is a function of X, right? So Y is a function of X. So I'm like, boy, that makes perfect sense. My inputs are X. My outputs are Y. I mean, it seems that that's the way it should be, right? But nobody else does that except for
something else that they got from Dr. W. Edwards Deming.
Is that from Deming?
No, I'm making that up. It wouldn't be a meeting unless you mentioned them.
He has to mention Deming.
And the Japanese. Japanese and that.
So then you have your analog inputs are AI, your analog outputs are AQ, and then your flags, for those of you that are PLC programmers, think binary files, right? Binary files are outputs that don't actually consume a physical screw address, right? So if I have an output that I just want to turn something on, like a binary file, I want to use that to recurse or turn something else on, I can use an output coil flag to M is what I can do, which all of this terminology is standard across all of the Siemens TIA Portal, SM 1200, 200, 400, 300, any of those, they all run off of that same type of technology.
Yeah, as well.
Yep. All right, basic functions. Basic functions really only apply, really only apply in function block. You know, when I'm talking about an AND gate and ladder logic, I'm putting 2 bits in series, right? When I'm talking about an OR gate, I put two contacts in parallel, right? But when we are programming in function block, we have AND, we have NAND, we have OR, we have NOR, we have exclusive OR, we have NOT. We also have these edge triggering. So if you don't know anything about edge triggering, I can trigger something on the leading edge of an input or on the trailing edge of an input. So you think of about a box coming down a conveyor belt, right? And there's a sensor. I don't want to trigger that input on the trailing edge. Box will fall right off the conveyor belt, right? So I want to trigger on the leading edge. But there may be times where I do want to trigger on the 1 to 0 transition instead of the 0 to 1 transition. So those could be examples. And then the special functions is really where Logo makes its mark. It does some really, really, really cool stuff. On delay, off delay, I love their symbols. You know, you can just tell by looking at symbols. Think about the upper wave is your input. So my input goes high. There's a delay before my output goes high. My off delay, the input goes high, my output goes high immediately. And when my input goes low, my off is delayed before I turn off my output. All of these things will make sense as you look at them and kind of figure them out. Up counter, hours counter, message text, all of that stuff is going to make stuff. Now, the mathematics instructions and analog comparators and stuff like that, a lot of that stuff is dealing with the analog side. So that's why you see it under analog. That's not, that whole analog section doesn't mean you have access to, like, you know, storing, getting numbers from a user on an HMI and doing some sort of conversion with those numbers. You know, these conversions are more about if I have my analog input coming in and I want to create an offset or I want to create a scale or something like that, that's what these are really for, is my analog.
Give us all insight into the analog mux.
You know, I have never used it. Have you ever played with it?
back when I was learning it, but I don't remember because it's been way too long. It's been decades.
I would have to do a little research on if that's multiplexer. Is that what that is?
Yes.
MUX. I've never played with it. The PWM's another one. I mean, I know what PWM is, right? Pulse width modulation. Some of this stuff you may not be able to use with certain logos. So like PWM, when you think about PWM, like especially if you're thinking about it from like an output standpoint or something like that, you're not going to PWM with a relay, right? You're not going to PWM with a relay because you're not going to switch fast enough. So they do make digital outputs that you could use something like that. So I mean, there's a few of these things like the Pi controller. A lot of that stuff I just haven't dealt with the analog side. The best I've done with analog is actually look at the analog, set the different levels, thresholds, turn something on, turn something off, and you can actually scale it a little bit too with some of the analog math.
So PWM would be really useful like with electric heat.
Oh, sure.
So if you have a solid state relay that's controlled by one of your outputs, and your PI controller maybe controlling temperature.
Yep.
You turn your heater on and off depending on how much you need.
Yeah. So what Grant just said there. So like if you're doing heating, right? And I want to have like a 50% duty cycle or 70% duty cycle. Like we were talking earlier about doing temperature control, just simple on-off control like your furnace does. But if I want to get a little bit more precision control, PWM would allow me to do that by controlling that duty cycle, right? That's essentially what you're saying.
How long it's on, how long it's off.
How long it's on? Yep. The pulse width and then the inner pulse width. What the percentage is by comparison. All right. So now what I'm going to have you do, I'm hoping.
Yeah.
And in that folder, there may be an icon that says LogoSoft Comfort
8.3.
version 8.3.
Shortcut.
So I'm going to double click on that. And I'm hoping that this will open up LogoSoft for us. We configured these computers today, so it's everything you're doing. It thinks it's the first time it's done it. So,
Welcome.
you might get two screens. You might get a screen that looks different than mine. It might look like a help menu or help file. Is that what you're seeing? If you close that out, right behind it, you should see something that looks like this. So that little help menu behind it, you may see something that looks like this. The only reason why mine's different is because I open LogoSoft all the time. You guys, it's the first time you've opened LogoSoft, so.
Mine's so much tinier than yours.
All right. God, I knew somebody was going to get. All right. So here's the deal. Please hit that plus magnifying glass. Take it out a few times. I want to be able to see your icons. We don't want to be able to zoom in on them. The other thing we're going to do is we're going to change this up a little bit. We're not going to, right now it's defaulting to function block diagram. So what I want you to do is, you see where it says circuit diagram here? I want you to close this circuit diagram out. And what we're going to do is we're going to go to File. And we're going to go to New. And I'm going to go slow. File, New. Oh. And mine's doing the same. File, New. And then we got a new ladder. So we're going to work in ladder diagram to start. Why? Because I'm a 25-year veteran of ladder programming of PLCs. That's what I do, right? So we're going to go to ladder, and then it's going to come up to this. Yeah. Now, logo's a little bit funky. If you're used to working with like Siemens TIA Portal, or even if you're used to working with like Rockwell stuff, it's a little bit funky in that there really aren't set rungs. You can kind of place things wherever you want. Where if you're working in TIA Portal, you have to work within each network individually, right? You can kind of place stuff wherever you want. We're going to start off, but before we even do that, I'm going to teach you guys what I tell all of my students to do when I'm programming in a micro automation. I click on this text tool, insert comments, and when I do that, I'm going to click up to the top right. And I'm going to type programmer. I'm going to put my name. I'm going to hit Control or Alt Enter. No, Control Enter, Shift Enter. There's some way to get down there. Oh, I thought it was Shift Enter.
Oh, Enter just did a character turn.
Oh, yeah, I need to put down.
Enter to go down? Oh my God. There was something I was using today where I had to use control.
Yeah.
Is it Excel that All right. So then project, this is going to be my logo demo. And then the date is something I always put in here, which is 11/3. I tell students to do this because when I'm looking at their code from afar and I'm, having a cold beverage as I'm doing their grading, I like to know who I'm grading, right? One thing about this.
How'd you get it to,
Yeah, one thing about this, you need to use these tools. You have a tool that's a selection tool, a connection tool, a cut join tool, and you have your insert comments tool. If you want to move something, you need to go off the comments tool, go to the selection tool, and then you can drag stuff around.
so you just press the comments tool and it,
Comments tool, then I click where I want to write the comment.
Yeah.
Once I have the comment tool, I just click where I want to put the comment. Yep. You got to toggle those tools on and off. Otherwise, what's going to happen is when you go to place something, every time you click, you're going to place another one of those things. So like if I have this tool on and I go click again, guess what? It wants more comments. If I click again, it wants more comments. So I just got to be careful that I turn that tool off and go back to my selection tool. Once you're at this stage, we're going to do this application. All right. Now, whether you like it or not, this is an old Siemens application, came out of my Siemens manual back in 2002. This is called tank fill, is what it's called. So we have two float switches. We have S6 float switch, which is telling me when the tank is empty. We have S5 float switch, which is telling me when the tank is full. For those of you that have not thought of a float switch before, when you open up the tank on your toilet, you ever seen that big ball in there? That little ball rises up, and when that ball rises up, the tank is full and it shuts off the fill valve. That's what a float switch is. So think of these float switches as, I've got a tank that I'm filling up with a fluid, right? I need to keep this tank full because we're making adhesive or we're making beer or we're making whatever. We got to keep fluid in this full because when I need it, I need to grab 10, 20, 30 gallons at a time. So I need to keep, 100 gallons of this ready to go, right? And so I can't be filling it on the fly. So what we have is we have a fill valve, Y3. So I'm going to use the liquid until it gets down to S6. S6 is going to close, okay? This shows a normally closed float switch versus a normally open float switch. That's a little flag on the side here is telling me that's normally closed. What that means is when the process is not actuating the float, it's going to close. So it's actually shown in its actuated position. It's showing the level is above that float switch, so S6 is open right now. S5 is also open. So as the tank level rises, what's going to happen to S5? It's going to close. So these two float switches are opposite in their terminology here. So what we need to do is we need to have something like S6. When S6 closes, I need to start filling the tank, right? So what we're going to do is we're going to come in here. I don't have an S6, but I do have something called a make contact under my digital constants here. I'm going to click on make contact. And I'm going to click right inside my menu here. Boom. As soon as I do that, I get I1. All right.
my laptop locked.
Uh-oh. Temp axis, temp axis.
And nothing I was doing was starting, so I got to start it back on.
So now I placed my first contact. Think of your contact as an input. It's like the light switch on the wall, right? The valve is the thing I'm trying to turn on. The light switch on the wall is the contact. I'm going to call this thing's going to open the valve. I'm going to go to comment under I1. And under comment, I got to go back and look at my diagram here. S6, I'm going to call S6 empty flow. S6 empty.
Underscore.
Yeah, this is an old, you don't need to do it in here, but this is a very common practice when you're doing PLCs. You cannot tag something without an underscore in Rockwell, like as an example, which makes sense, right? We don't want to have unknown amounts of spaces or null characters or dots so we do S6 underscore empty. And I'm going to hit OK. So that's my empty float switch that's going to turn this thing on, right? As soon as that closes, I'm going to start filling. So my fill valve is Q1, or we call it Y3 in this case. So I'm going to go into here now. Oh, hold on a second. I had these backwards, didn't I? I had I1 as S5 full. It doesn't matter. We're going to do it this way. So S6 empty will trigger this. And then we're going to go to a coil, which is going to be my fill valve. Think of an output as something I'm turning on right now. So if there's a solenoid actuated valve, it's kind of like a relay, right? I apply power to it, that valve opens up. I remove power from it, that valve is going to spring closed. So that's what I'm going to do. So I'm going to go to Q1, I'm going to put a comment on it, and I'm going to call this my fill valve. I'll do the underscore as well. So now I have my S6 empty and I have my fill valve. Now this is kind of like the hello world of PLCs is what this is. Ready? What we're going to do is I've got my connect tool right here. So you had your selection tool. You've got your connect tool. You've got your text tool. You also have that cut and break tool. What I'm going to do is I'm going to grab that connect tool. Are they keeping up with me, Andrew? All right. I'm going to grab that connect tool. Yeah, shoot your hand up. And I'm going to connect to that rail. When I have the connect tool, it's like a wire. I left click on the node, and then I hold and I drag over to that other node. So I'll do that again. I'm going to left click on that node, drag over to that other node. All right? That's how I'm going to connect it. Once you get to this point, you have just built, believe it or not, you've just built your first PLC program. We would download this to the PLC, and every time S6 went empty, every time that empty float switch closed, your fill valve would open for about 1 second, and it would not fill. Why? Because as soon as it closed, it would start filling up, and then it would come right off again, right? So we'll talk about that in a minute.
Keep my, it's not a parameter, it's a comment. That's why it's not keeping the.
Yeah, it's a comment. Yeah, when you go into here, good call. We do not want to type in the block name. The block name is not what we're dealing with. We are typing in the comment.
Yes.
S6 empty is a comment.
And I chose an M1.
Fill valve is a comment is what it is.
And you have to go down to the Q's, which I didn't do. I just was doing it automatically.
Tell your buddies. I got food.
Oh, you do?
Yeah. I kicked you guys out earlier, remember? Wasn't you guys I kicked out? Take some food with you. There you go. You're welcome. So you go into that comment, and that's where you put in that tag that you want. That's where you're going to put that tag. Now it's the hello world. This is the best part of Siemens logo right here. The best part is, Tom, didn't you used to sell these things?
I was selling to, different,
I didn't know if they were, but I sold the shit out of them. Very good salesman.
You don't have to be able to drive a Ferrari to sell one, right?
This is not an installment, I would say.
All right. The coolest part of logo is right now. This button right up here where it says Sim, that Sim button. I'm going to click on that Sim button, and now I am in simulation mode. What that means is right now, everything that's red is hot.
yes.
The second if I put my mouse over that float switch, S6 empty, and I click on it, my fill valve just turned on.
Yep.
If I click on it again, my fill valve turned off.
Yep.
My fill valve turns on, my fill valve turns off. So now I have the tank trying to fill itself up. There's only one problem with what we have right here, right? When I go look at this tank, you notice where S6 is, right? Empty there? No, what's going to happen is that switch is going to close when it's empty. It's going to start filling, and the second it gets above that switch, it's going to open up again. So what it's going to do is it's going to cycle. It's going to go fill, don't fill, fill, don't fill. Because what's going to happen is I get down to here, The switch closes. I start filling out with Y3 there. It starts filling up. As soon as I get above that float, even just a little bit, it's going to open up again, right? So what I want to do is I want to fill till I get to S5. And Blake, what do we call that when we need to maintain something? If I have like a start push button and I only get it momentary, but I want to keep it until something else, a latch or a holding contact or a sealing contact. Exactly right. So what we're going to do is we're going to create a latch. So I'm going to turn off the simulation now, and we're going to create a latch. We want to latch in Q1. We want Q1 to be our holding contact. So what we're going to do is we're going to grab another make contact. We're going to put it right in parallel with the S1 empty. Except instead of it being addressed to I1, we're going to address it to Q1. Q1 was not available until I consumed Q1. So until I created a Q1 tag, I couldn't tag an input to Q1. But now that I have a Q1 coil, I can tag an input to Q1. So I'm going to click on Q1, I'm going to hit OK, and now that's my fill valve. And then I'm going to do this. I'm going to go ahead and drag this over here. I'm going to drag it over here. So now, when I turn on S6, it's going to start filling. And the fill valve itself is going to hold itself on forever. Nothing, now it's going to do what Paul's talking about. There's no way to shut it off now. But what we know is I need a way to shut it off. And what's the way I'm going to shut off that fill valve? We've only used two things. We've used S6 and Y3. So we've got our fill valve and we have our empty float. What's going to be the thing that's going to tell me when the tank is full? S5 closing or S5 break contact as what Bob is talking about there. So what I need to do is I need a break contact of I2, which I'm going to put a comment on that. I'm going to call this, oh, I got to be really careful here. Here's one goofy thing about logo. You ready? Place I2 right now. Don't put a comment on it yet. Just place I2 as a break contact, not as a make contact, but as a break contact. Place I2. Now it's placed. Once you've placed it, go back into it and put your comment on it.
Wait a second.
So it'll be your S5 full. So I want something that looks like that. I want I2 as a break contact. For those that are new to PLCs, think of it this way. When it's a make contact, it goes true when I apply power to the screw terminal. When it's a break contact, it goes false when I apply power to the screw terminal. So it's going to turn off when I turn the thing on. So normally it's going to be closed and it will open when I energize it versus the other one normally will be open and I'll close when I energize it. So now I want to get rid of this line. So I got to make sure I've got that selection tool highlighted because I want to get rid of this line right here. And I want to place this guy right here. I clicked on the selection tool, and then I clicked on that line, and I hit the delete key.
So I'm used to those being called normally open, normally closed. That
Siemens uses the term make and break. Yeah, normally open, normally closed, same thing.
when it's not powered on.
Oh no, it gets worse than that. Rockwell calls it XIC-XIO, which makes no sense to anybody on the planet, right? Yeah, it's very cryptic. Which they're coming from a relay background, which is weird, but it's fine. So this is what I want wired up. That's our goal. If you've kept up with me so far, and you've got what I got on the screen, A+. Yep. There's no grade for this class, but A+.
I can leave the class in?
You can, but you won't want to. Mm-hmm. I'm gonna let Bob catch up, and then once we have Bob catch up, we're gonna simulate this program. Realize in the real world, we would dump this to our PLC now, and our PLC would just run. It would be wired up to the 2 float switches and the fill valve, and we would just let this thing run forever and ever and ever. Uh-oh. She's sitting next to Ed. That's the problem. Yeah. Check on Charlotte too. Sally, you doing okay?
We want to be able to put the output of the S.
Huh? No, I like XICX. I don't mind XICXIO. It's just, that's a Rockwell term is all it is. Oh yeah. That's Joey White that taught you that. Guarantee you that was Joey. Yeah. Yep.
So other terminology, how our SD switch, no, switching.
Oh yeah, yeah.
Full is not.
There you go. That'd be the same thing. Yep. Yep.
Okay, now how about it? Selection tool. Okay, and get rid of this.
All right. Once we get Charlotte caught up, I think Blake, you guys are okay. Maybe you'll figure it out. Got it. Yeah. All right, I think I got one more getting caught up here. Once we get Bob caught up, we're going to jump in and simulate this. Yeah, we don't want a flag bit. Flag bit would not actually turn anything on. It's just a binary file is all it is.
Sally, how you doing?
Just trying to figure out one thing.
Oh, you're right with you?
Yeah, there we go. Now you should be able to go clean that.
I'm gonna walk you around. You're gonna help Sally out?
Yeah.
I'll put it down.
I just need to.
What do you got in your bottle there, Grant? What do you got in your bottle? Oh, something that you can't. What is it? What was it that the guy said in Clockwork Orange? Sparrow, you know, country road.
I don't remember that. I've seen the movie a couple of times, and I don't remember anything except for singing in the rain, taking the crap like somebody else. That's all I remember.
Wow.
It's been a long time.
Yeah. I watched it a year and a half ago. It was on. Make sure you draw a line or something. So I decided to watch it. Also, I think all my high school buddies, we drew. All right. Or out or any white clothes or a cane or anything.
So let's simulate this now. So what I want to do now is I want everybody to hit that simulate button.
You mean touch it?
Yeah, touch the simulate button.
It
Fell asleep on you again? Locked up on you?
It just, the screen went blank.
Oh.
So I don't know.
So remember what's going to happen. Your tank level's falling. When your tank level gets empty, we click on I1. Boom. So the float switch closed. And we start filling. The Y1 fill valve opens up. What are we doing? We're dumping fluid back in the tank, right? As soon as I start dumping fluid in the tank, that lower float switch opens up. So I can turn off this lower float switch, but I keep filling, right? I keep filling because I want to go all the way up to the top, right? So even though I turned off S6, I'm still filling through Q1 and S5. This is called a holding contact, or a latch is what this is called. Now I'm going to run all the way up. And when I get all the way up to S5, way up top, eventually that float is going to close. When that float closes, this opens up and your fill valve closes and you're no longer closing. Does that make sense? Yeah. There's one on the side over there, Andrew.
Oh, yeah, there we go. Right behind me.
There we go.
I have no light there, so this is a power supply. Is it not plugged into the power supply? No, it is. Looks like it's full of Siemens. Yeah. It might not bad. That should work. Here, let's just switch to Grant's. Grant's right next door. Yeah, yeah. You should be fully charged. Okay. That's it. Hopefully the socket's good. Yeah, it's working. So the battery pack.
Yeah.
Yeah. Thank you.
I don't know how it happened, but I knew.
And we didn't have to follow the money on that.
Yeah.
Normally, when you have something go bad, you gotta follow the money.
Yeah, not this time.
Not a political, not a political.
Thank you.
Ed, did you get it working?
Yeah.
Charlotte, you're good?
Yeah.
Grant, you're good? Tom, you're good?
I think I'm good. It's the same looking.
Yeah.
thing, so it'll-
Paul, you're good, right? Bob, you're good. Sally, did you get it working? Nice. Blake, we're going to do a new one now. I'm going to turn the simulator off. I'm going to go off script for a second. I'm going to go off script because I want to do something kind of cool. And what I'm going to do is I'm going to pick that select tool. I'm going to draw a box around all of these things. Left click, draw a box around everything. This is where Grant's good AutoCAD electrical skills come in so handy here. He's like, I draw it this way, it touches them. This way I got to enclose them, right? You know, highlight all that stuff, and I'm going to hit the delete key.
Oh, yeah, you got it.
So just pick the select key and then draw a box around everything you want to delete. Once it's all highlighted, smash that delete key. Everything is gone. Everything's gone. All your hard work's gone.
Yeah.
Here's what we're going to do. We're working at Summit Brewing right now.
Yay!
There are 12, there's a conveyor belt full of cans. These cans of beer are coming down the conveyor belt. There's an inductive sensor that they go past. Inductive sensor senses metal, so it can sense this aluminum. And so it senses each can as it's coming by. How many beers are in a 12 pack there, Tom?
In a 12-pack?
Yeah.
11.
Good guess.
I drank one.
12, well, there you go. So 12 beers in a 12 pack. 12, for those of you that don't drink beer, I'm drinking root beer. So it's 12 root beers in a 12 pack of root beer. What we're going to do is we're going to make it really, really easy. I'm going to grab a make contact. I'm going to place that make contact right here. I'm going to put a comment on it. I'm going to call it my can sensor. I'm going off script because I want to do something that gives them a little bang for the buck, but is simple and shows a different technology, right? So we got a can sensor. So every time one of these comes past, this input's going to turn on for a split second. And once it's passed, it's looking for another one. So conveyor belt full of cans coming down. All right, then I'm going to go down to my special functions. Actually, underneath, not timers, but counters, I'm going to grab my up-down counter. Grab my up-down counter, and I'm going to place it right here. I'm going to zoom in on it. You guys don't have to do this, but I'm going to zoom in on it a little bit. Neat thing about the logo, you could hit F1 if you wanted to. You could right-click on it if you wanted to. You could look at the block properties. You could go to help. I go on help. I don't know where help went. There it is. It would tell me what an up-down counter does, and input pulse, increments or decrements, an internal value depending on parameter setting. The output is set when the configured threshold is reached. So what I'm going to do is I'm going to take that sensor, I'm going to wire it up to my count pin, my CNT count pin. That's what I'm going to wire that up to. And then I also, with that counter, that up-down counter that I just set up, I also can configure a comment on that as well. So I'm going to double-click on C1. I'm going to go to the comment, not the block name, but the comment. I'm going to call this my can counter. Looking good.
I don't have any names on mine. I think it's in the settings somehow. The comments are.
Under comments, double click on it and then go to the comments. So yeah, if you go into here where it says comment tab, that's where you can type in your comment.
Yeah, so call it a can counter. Let's see if it'll show up for you. Okay.
Now we want to set our thresholds.
Okay,
We want to set our on threshold and our off threshold. So our on threshold is, what do we want to do? What are we looking for? Yeah, I zoomed in to be able to see the pins. Yeah.
there we go.
So if you double click on this again, and then when you look at the counter, you'll see the on threshold and the off threshold. The on threshold, any guesses for 12X? 12. Yep.
I thought it was the other one.
A 12 pack with 0 cans in it is not very,
Oh, it's my last stuff too.
yeah.
Although profits go up.
Yes, they do.
Exponential.
The off threshold does not make as much sense. In order for the counter to turn off, the count has to be less than it. So I'm going to put in 1 because I want my off threshold to be 0, right? So when it's 0, the counter bit is going to turn off. Let me show you what this means in a real quick and easy example. I'm going to go and grab one more input.
So the off is 1.
The off is 1.
Yeah. Yeah.
That is not real intuitive. All right. I'm going to, real quick, I'm going to move my stuff down. I'm going to slide my stuff down a little bit. You guys don't have to do this. I'm only doing it so you...
Is that 1, the first one in the next series of 12?
No. So when the count gets to 12, the counter bit is going to turn on, the done bit. And then it's going to stay on until somebody resets the counter to 0. But if I reset the counter to 0 with an off threshold of 0, it won't reset. So the off threshold has to be 1 greater than what I want it to reset at. Knowing that you may not always use 0 as your reset. Let's say that you're using 2 different counters. You're counting from 6 to 12 or from 0 to 12. You know, maybe you're counting the number of cars in a parking ramp or something like that. Who knows?
Basically, the threshold you must cross.
That's it.
In order for it to happen.
Now, what I want to do real quick is I want to create another input, and I want to call it reset. I'm just going to call it like a reset push button. So I'm going to wire this I2. So I've got I1 set up to my can count, my counter. I've got I2 set up as a reset. That's the R pin. Again, you can zoom in on this to be able to see those pins.
Again, I'm trying to remember how to get this stuff. And so it took me a long time to get it here. And put on all reset. There we go.
If you're not keeping up, I got good news and bad news. You may want to know what the bad news is? You're going to fail the class, right? Want to know what the good news is? We offer this class again next year. Nobody's failing the class, I promise. All right, so I have a can sensor, I1. I have a counter with the parameters set for 12 on, 1 off. And then I have a reset, I2, wired up to the reset pin. Who's got a question?
Yeah. Anytime that I try to drag on the contact, it gives me another can sensor. Like that would not.
Yep, you're fine with that. You might set it to I2. And then for the comment, no, that's what you want to do. And something other than the comment, once you place it, go ahead and switch to your slide. There we go. Can sensor. There we go. Okay. Yeah. And then just double click on it and you say press enter.
Oh, okay.
You're changing to I2 and then go on there and change down.
Oh, got it.
And then wire.
Now, yeah.
Yep.
Now it's a do for
Yeah, and it's really weird. You got to place the block first, and then you.
Yeah, the comments are sticky.
Yeah.
So what that means is if you just place another comment or another contact, it's going to try to use the comment from your previous contact. So you almost have to place it, change it, place it, and then change the comment. It's a little bit sticky. It's one thing I don't like about this. The software is a little bit goofy, but if that's the worst you got, it's not too bad.
So we'll have this one.
Oh yeah, that would be right there.
All right,
Because it's active. Then I got
we're going to do one more thing now. So throw you guys into a craziness here. I'm going to put a coil in here. So I want to grab a relay coil. I'm going to drag a relay coil and place him right here. Not there, though. That's not where I want him. I want him right about there. And then I make contact right about there. But this is going to be addressed to C001. That's what I'm adding in there. Relay coil of Q1. And then the contact feeding Q1 will be a make contact addressed to my counter. So my counter done bit, when my counter is done counting, C001 contact will turn on, which will turn on Q1. I'm going to call Q1 my packer. Oh, I want to make it capital letters like the rest of them there. So I placed a make contact, and because I have C001 counter in here, if I scroll up from the eyes, I can find C001 in here. Yep. Charlotte, at the beginning of the day, you couldn't spell PLC, and now you are programming PLCs.
How did you do the can counter C001 again?
So I did is I placed a make contact right here or anywhere. And then if you scroll up, instead of selecting I1, if you scroll up, the counter is available now because you have a counter in your program.
Gotcha.
So now that you have a counter in your program, you can address a contact to it.
Okay, so make contact, bring it over. This comes up as reset.
But you can place it and then, go up to C001 or whatever you're going to do. Remember, you don't want it to be I2. And your comment is sticky. What that means is because you've already commented C001, it is commented with any C001 item you place in there. Make contact, break contact, doesn't make a difference. If you address it as C001, it's going to take on the same trait as your C001 counter, which is that comment. I'm going to do a quick walk around and let's see everybody with what I have on the screen. Paul's got this down cold. That?
Yeah. So far, so good. Where's my cue?
There you go. Is that good?
Oh, yeah.
Oh, yeah. How many of you
Tom's got it down cold.
Oh, yeah, it might be that it's too close to the top. Comment is up above the...
And that's, I wouldn't worry about that, yeah.
That's all good.
Right. Ready, right?
Yeah.
I get Q3 as my input, but I just find Q1.
Are you already using Q1? Go ahead and hit cancel. Get Q1 somewhere else.
There we go.
Although I noticed that the candidates have something that looks.
Oh, it does. It has a Q1 set, it has a Q2 set there too.
Oh.
You just placed a couple extra ones. How they do that? I wouldn't worry about it. Just use Q3. You're fine.
Oh, okay. Yeah, you're fine. Okay. Apparently it works.
Yeah. Let's talk about this for a minute now. Before we run this, what are we looking at? So I've got a can coming down a conveyor belt. That can sensor, every time it goes by that can sensor, I1 turns on. I1 turning on goes to the count pin of my counter. What's going to happen to my count? It's going to increment by 1. The next can increments by 2. So I1 is going to go on, off with each can. Think about this like a switch, turning on that sensor, turning on that input, which then goes to our count pin. When I get to 12, as soon as I get to 12 cans, the done bit, the C001 make contact, or for Grant, normally open contact. That normally open contact is going to close when I go over the 12 threshold of the counter, greater than or equal to. When that happens, the packer is going to turn on. Once the packer turns on, I'm going to take all 12 cans, smash them into a case. That's going to trigger my reset, and we're going to be off and running. So we're going to go to simulation right now.
Especially if it's a Green Bay packer.
Yeah, then for sure. So now what we're going to do is we're going to trigger the count by triggering that can sensor. Click the can sensor on, off. On, off. It was. On, off, on, off. Notice what's happening to your count. 4, 5, 6, 7, 8, 9, 10, 11. Notice Q1 is not on yet. 12, Q1 turns on. Now we are packing at that point. Now go.
So the down bit on the
Mine did the same thing for some reason. My reset was on already. Now that I'm at 12, the packer runs, everything's good. I'm gonna hit the reset button. We start it all over again. 1, 2, 3, 4, 5, 6, 7, 9, 10, 11, 12. My packer's on. I'm packing. The reset turns on, it resets. Now I'm going to show you something really cool. You thought that was cool? I'm going to show you something really cool, which is really powerful. So we're going to turn this simulation off for a second. And we're going to add in another element to our program here. What we're going to do is I want to display. So maybe these cans are moving pretty slow, right? Maybe they're moving pretty slow. And I want to keep track of how many cans have come across. Except I don't want to have software to go look at that. I want to have a little HMI screen where it's telling me how many cans I've counted up to. So what I'm going to do is I'm going to go into the special functions down near the bottom, miscellaneous. I'm going to grab something called a message text. The message text for what we're doing today is going to just tell us the number of cans. But in the real world, this message text could be relayed to KTP 400 HMI or the Siemens TDE HMI. It could be relayed to anything. And what I'm going to do, I'm actually going to make it even a little simpler. I'm going to zoom out just a little bit. And I'm going to connect that message text directly to the rail. So what that means is that message text is always enabled. It is always on. It's got a 1 on it at all times. I don't have to wait for a switch. I don't have to wait for anything. That message text is always there. What is that message text? For the logo, that message text is going to be this little screen right here. I'm going to display something on that little screen. All right. And if I had the TDE, I could relay that to the front of a control panel. If I had the KTP 400, I could relay that to an actual HMI. And if I had the cloud version, I could look at this on my HTML on a web server. I could look at this data on a web server. Keep track of the number of cans, total, number 12 packs, whatever I want to look at. So what I'm going to do is I created that message text, connected it directly to the rail. Now I'm going to go into that message text, and what you'll notice is when you go in there, it says, wow, you got some cool stuff in here. The green side of the screen is what's going to be displayed on the logo screen. The blue side of the screen is what would be displayed on a TDE or a KTP 400. We're not using those, so we're only going to work off the green side of the screen. So what I'm going to do is in the green side of the screen here, I'm going to say can count. And then right below where I write can count, I'm actually going to double click. I may have to try, I don't know if I'm going to drag it or double click it, one of the two. But I'm right below where it says can count, I'm going to put the can count. Double click on that. And I'm going to put notice I can put different values here. I want the counter value. So I could put the on threshold if I wanted to display that. I could put the off threshold if I wanted to display that. I could put the starting value if I wanted to display that. I could put the current time, the current date. It's got a real-time clock. I could do the message enable time, whatever I want. I want to put the counter value. So I'm saying can count, and then right beneath it, I'm going to put what that counter value is, and then I'm going to hit OK.
Let's see.
Double click on that, show everybody.
I didn't see how you put the counter in there, how you switch the, yes, there it is. Yeah. threshold.
You got it, huh?
There it is. And then we'll pop like stream. Yeah, that's why we're these things.
And then when you hit OK, now that you got that message text, if you go to simulation, you'll notice right off the bat, it tells you what the can count is. What's the can count? 0. Every time I hit that sensor, it would be displaying this onto an HMI. It'd be displaying this on the screen. And it's displaying it when I get to 12. Boom. Now everything's running again. I can go ahead and hit the reset. It goes back to 0. Remember where this will be displaying. In the real world, this will be displaying right here is where it would be displaying. That's if you're displaying on the Siemens logo on the front of it or the connected HMI for it, the TDE or the KTP 400, whichever one you want to use. Really, really simple. For those of you that are programmed in Rockwell, almost too easy. Almost too easy as far as what we can do with this thing, right? It'll let you go up to 160 if you want. But in the real world, we would make sure that once it packaged, it would hit that reset button. Remember, you got to hit that reset button to simulate the reset after that package comes through. So you could think of that reset being like as soon as the case leaves, now that triggers a different sensor that resets it and we start counting again. Yep.
And it couldn't return.
No, it wouldn't be a manual reset, yeah.
You could do it on a edge. Yeah. Comparison.
Now, so just so you guys know, I know everybody thinks I'm BSing them when I say, yeah, they use this at Summit Brewing. Yeah. So I got to show pictures, right? Because if I don't have pictures, then it didn't happen. Nowadays with AI, I could probably just create all AI images, but, just say, yeah, AI, create an image of this.
In the background, holding a can of Summit.
Yeah. So this is back when I first started at Dunwoody. I didn't realize it wasn't a good idea to take my students on a field trip to Summit Brewing. So...
There's some ethical issues with that, yeah.
So when you think PLCs, logo, that is what we call micro automation. S7-400, this is what I call macro automation. When you look at the number of slots and the number of I/O points, this thing could legitimately have 250 or more I/O points just in that one rack.
Oh yeah.
Just in that one. That's an S7-400 PLC. That is a monster. And not only is it an S7-400 PLC with a CPU down here, but it's also got all of this additional I/O up here as well. I mean, this is a monster. So when you talk about process control, you're not going to do it with logo, right? There's a lot more going on. However, and what's this called, Bob?
This is an HMI.
And this is their SCADA system. Yeah, this is the HMI SCADA system, monitoring all of the process variables. And you get far, there's my students.
They're happy. They've been drinking some beers.
Yeah, they had a few beers. That's not a logo. However, when you get to the keg line, God, I hope I have a picture of it. If I don't have a picture, I'm going to be sad. There's your bottling lines. Oh, here's the kegs. There's the kegs. Look at what it is.
Bada bing.
So what the Siemens logo did, this is filling kegs. Filling a keg is the simplest thing in the world. You would not believe how simple it is. Literally, it's what you guys just created. It's a fill valve and measuring how much fluid is in the thing. And they measure how much fluid is in the thing by the weight of the keg. So they know the initial weight and they know the final weight. And that's how they fill the keg. And they do it all with the Siemens logo. Trivial. I mean, it was literally, that's a really old one.
Yeah, here we go. And you can also see it's showing the inputs and it's showing that number 3. It's kind of faint to see as they get a distance. Yeah. But it's fairly high, so we see that one's getting a signal.
Yep.
And we can see if any of these outputs were on, we'd be able to see which ones are on. So that screen is awesome for troubleshooting, in spite of its cybersecurity implications. Fully qualified drinkers are allowed into Summit. So
yeah, there's your Siemens logo right there.
yes.
Qualified and authorized. True.
DJ, what is the significance of the two screens?
So the screen on the left would be the logo display
On the front.
This is what would be on the PLC on the very front of it. So when you look at this picture of the logo, it would be on this screen right here. Okay. That's where it would be displaying. The TDE is your extended touch display. That's going to be, you can buy a separate HMI that will display the same thing that you can put on the front of the control panel, because usually the logo's inside the control panel. I've seen people, what they'll do is they'll put like a clear window, or like you guys have done with control panels, put a glass front on a control panel, and then you can actually see inside and see what the thing's doing. But normally we don't do that. Normally what we do is we have the display would be separate on a connected device, connecting into the PLC is what it would be. Network switch.
Yeah, normally you have 480 volts going into that panel, and you can't have a glass little thing there.
Yep.
Or flash.
Will definitely be more flashy.
Yeah.
More flashy.
That's the window to observe the arc. And if you're seeing sparks, you want to kind of leave.
All right. This is my last one, folks. I got one more that'll take about 15 minutes, and this is a good one because this one uses the real-time clock of the logo. So in my old house, I put in my own sprinkler system. And when I did it, I had a logo controlling the entire thing, and it worked great. When I bought the new house, the sad thing was when I sold the old house, I legitimately got a call about a month after I sold the old house and said, well, what is this crazy sprinkler controller I can't figure out? So never will I do that again, because it worked great for me, but didn't work great for the guy that bought my house, right? He had no idea what he was looking at. So what we're going to do next is I'm going to get out of this one, turn off. Oh, before I go away from this though, let me show you this real quick, because you're not going to want to see. So this is ladder logic. I want to know what this looks like in function block. All I do is click this button right here, convert to FPD. See that convert to FPD button? There it is in function block.
Circuit diagram number 2.
And when you look at it in function block, it sometimes helps to kind of rearrange things so you can kind of see what you're looking at. But there you are in function block. You notice in function block, the message text is completely isolated. Well, guess what? They didn't have anything in common in ladder either, right? The message text was connectly directed to the power rail. So here it's connectly directed to the power rail as well. But to do that, they just use a high input. It's always on, right? Then in here, I have the counter. I1 counts, I2 resets, and I go straight to the output instead of having a bit triggering an output. So you don't see AND gates and OR gates and stuff in here, but that is it in function block diagram.